So today we're going to talk about expressions and evaluating those expressions. And this is really important because in a lot of systems and a lot of technology, what happens is the person who writes the code for that program has to tell the program what to do based off of what the user does, right? Like your calculator on your phone uses a lot of algebra because it has to be able to take what you tell it, like 3 plus 4, and know that it's supposed to add 3 and 4, right? Like if you accidentally coded the buttons backwards and instead made the little plus button a subtraction, it would do it backwards, right? It would do 3 minus 4 and stuff like that. So in programming and coding, it's important to be able to take an input from the user and do something with it. And you have to, that's the heart of algebra. Algebra is working with quantities or numbers that you don't know what the number is, but you still have to be able to work with it and use it to get a result in the end that you want. Okay, so I want you to imagine like you're designing a game where someone starts with $50 and they have to purchase an item to start the game. So you think about like Call of Duty or something like that. When you purchase weapons at the beginning, you start with a certain amount of money, and then the computer has to be able to figure out, hey, if let's say you have $1,500, if you purchase something for $200, it has to be able to update how much money you have. Otherwise, you'd just be able to buy whatever you want, and then the game wouldn't be fair or hard. So basically, what we're going to do here is we're going to start talking about an easy example of like, hey, if we start with $50 and then somebody spends a certain amount of money, how much would be left in their account? So let's look at that. Okay, so if somebody starts with $50 and they spend $5, how much money would they have left? They would have $45 left, right? You just do 50 minus 5, and it gives you 45. If they spent $10, how much money would they have left? They'd have 40 left, right? Come on, Apple Pencil. Okay, how about if we spent $15? You're going to do 50 minus 15. That would give you 35. If you spend $25, 50 minus 25 would give you 25. If you spent 30 and subtract that, you would have 20, right? 50 minus 30 is 20. So here's where it starts to get interesting. Let's say that you're trying to program this and you have to be able to tell the computer, hey, if the person spends this much, figure out how much is left. What do you tell the computer to do? You tell the computer, hey, just take 50 and subtract 30, and that'll give you 20. What if you don't know how much the person's going to spend, right? You have to tell the computer, hey, the person is going to spend a certain number that I don't know. But what I want you to do is I want you to take that number and subtract it from 50, okay? So what we're going to do here is we're going to say that the amount of money remaining in the account here after the person has spent X dollars is going to be $50 minus X dollars. Or maybe, if you don't want to put the dollars in there, you can just say that number would be, 50, gosh, my Apple Pencil's not working, 50 minus X. Okay, I hope that makes sense because you're just taking 50 and subtracting whatever the number was over here. Okay, so we'll put a little dollar sign in front of that. So whatever 50 minus X is, that's how much money would be in the account. Okay, so now where it starts to get really interesting is you can start to make everything kind of unknown to you. So imagine that instead of starting with $50, you allow the user to pick their own starting amount, right? So maybe you're in a game where they buy their upgrades and whatever, and you don't even know how much they start with. So what we're going to do now is we're going to say, hey, instead of 50, let's say they started with Y, okay? So literally the letter Y, okay? So now the question is, how much money is left in the account after they spend, certain amounts? So let's go over here and say, hey, if they started with Y, how much would they have left in the account? So if they started with Y and they spent $5, how much money would be left? It would be whatever Y minus 5 is. Okay, so like if Y was 100 and they spent 5, you would do 100 minus 5. That would give you 95, right? But we don't know what Y is. How about if they spend $10? Same idea, right? It's Y minus 10 because they spent 10. Next one, y minus 15. If they spend 15, whatever y minus 15 is, that's how much they would have left. If they spend 25, it'd be y minus 25. If they spend 30, it'd be y minus 30. What if they spend x dollars? So if they start with y and they spend x, how much money do they have left? They have whatever y minus x is. This is where you start to get into, math where there's literally no numbers, right? It's, hey, whatever they started with, you need to subtract whatever they spent, and then you'll get a number here. I don't know what the number is right now because I don't know what y and x are, but you'll get a number, right? Like if they had 100 and they spent 30, when the computer does 100 minus 30, which it knows how to do simple addition, subtraction, stuff like that, it'll get 70. And you'll say, cool, that's how much money they have. So this is how a computer and certain apps and games are able to take user inputs and provide a user experience that's really enjoyable and actually works, is because you're able to code the program to understand, here's what they started with, here's what they spent, whatever this subtraction is, that's how much they have left, okay? This is why variables are important, because there are many scenarios in life where we don't know what the input's going to be from the user, okay? So these right here are called expressions. We're going to use these a lot in algebra, okay? So y minus x is an expression. Y minus 5 is an expression. Y minus 25 is an expression. So we're going to kind of talk about expressions, and we're going to get really comfortable working with them, because we're going to have to work with them a lot in algebra. We're going to work with quantities like x and y where we don't know what x and y are, but we can still manipulate them and use them however we want to get the result that we want that's still numerically valid. Okay, so here are just some examples of expressions. So basically it's just any combination of a quantity of numbers and variables. So if you've got 4x squared, that's an expression. 2 is an expression. 1 minus 4x is an expression. 7 minus 4 times 3 is an expression. These are all expressions here. Notice how there's no equal sign. If you have an equal sign, we tend to call those things equations. Okay, so this is an important distinction. Let's go on to the next page. So this next page just kind of serves as helpful notes. I'm not going to make you write any of this down, but basically you're going to hear a lot of different terms when you deal with expressions, like, hey, what's the difference between this and this, right? What's the difference between 7 and 3? I'm just asking you, how far apart are they? So you do subtraction for difference, okay? If I ask you for the sum of two things, I'm just asking you to add those two expressions. So you would add them together. And if you can't add them, like x plus 9, you just write x plus 9 and say, that's all I know. I don't know what x is. I can't tell you what x plus 9 is. Quantity is where you're going to group things together, and oftentimes you'll put them in parentheses. So if we say like twice the quantity of 4 subtracted by 7, like in this example, we're going to write that as 2, and then in parentheses we're going to put 4 minus 7. So typically you would do 4 minus 7 first, then you would double that, right? The quantity of 4 subtracted by 7 is negative 3, and then if you want twice that, you would do 2 times negative 3, it'd give you negative 6. You could also distribute here if you really wanted to. That would work. Quotient means that you're going to divide. So if I ask you for the quotient of 2 and 5, it's just saying, hey, it's this thing, the first thing, divided by the second thing. Product means multiplication. So literally the product of 4 and n is 4 times n. More than or greater than. So if I say, hey, 5 more than a number, like if you don't know what the number is, usually we use like x or n or something like that. You would just say x plus 5. If I say less than, that means I want 4 less than a number. You would do like a number, x minus 4. Be really careful. If I ask you for 4 less than a number, like if I want 4 less than x, it would be x minus 4, right? It wouldn't be 4 minus x. It would be the number minus 4, not 4 minus the number, okay? So be really careful with that. If I want 4 less than a number, say x minus 4 or n minus 4. Because these two things here, x minus 4 and 4 minus x, are very different. Like you're going to get different quantities, right? Imagine like your number was 9, right? Like what's 4 less than 9? It'd be 5, right? You would do 9 minus 4 would give you 5. If you do 4 minus 9, what would that be? 4 minus 9 would be negative 5, right? And negative 5 is definitely not 4 less than 9. So you wouldn't want to say that. Okay? And then exceeds is a term you're going to hear a lot. It just means that you're more than something. So to say that a number exceeds 5 by 4 means that a number that you're working with is 4 more than 5. So like 9. Okay, so let's look at some examples here. Example 1, Mark starts with $15 in his bank account and adds $5 per week. Write an expression that can be used to determine how much money Mark has in his account after X weeks, okay? So, like, obviously, if it was like 3 weeks, you could just say, hey, like, he starts with 15, and then it's $5 per week, and if it's 3 weeks, you would just do 5, and then you would do the number of weeks, right? So maybe if it's 7 weeks instead of instead of a 3 here, you would put, come on, Apple Pencil. Of course, it's not working here. Instead of a 3 here, you would put a 7, right? If it was 7 weeks, right? You would do, starts with 15, and then you add 5. How many times? Well, you'd add it 7 times. So here's where it starts to get a little tricky. What if instead of a number here, I told you it was X weeks? Like, the computer program doesn't know, but it needs to be able to calculate it based off of some number that the user inputs. Well, this is where the X, the variable, comes in, right? So if he starts with 15, and then we're adding $5 every week, and we don't know how many weeks there are, right? What do we put in where the question mark is? Well, that's where the X comes into play. Whatever X is, if you multiply it by 5, that's how much money is going to be there for those number of weeks, right? So if it was 10, you would do 5 times 10, and what would happen? You would get 50 here, okay? So this is actually literally it. This is our answer. We don't know what X is. We don't know how many weeks it's been. But if you do 15 plus 5 times the number of weeks, that will tell you how much money he has in his bank account. So this right here is an expression which we can use to indicate how much money is left in Mark's account after a certain number of weeks, where X is the number of weeks. This is super, super useful. Let's look at another example. Write a symbolic expression to match the written expression. 7 more than twice the difference of a number and 6. So 7 more than twice the difference of a number and 6. So the way I kind of think about this is, I'm going to read this first. So twice the difference of a number and 6. So if you took a number and 6 and you wanted the difference of that, I would write that as a number, x minus 6, and you want twice that, so I would double that. And then you want 7 more than that, so I would add 7 at the end. You can add 7 at the beginning, it doesn't really matter. Like if you put 7 plus here at the beginning, you could do that. But I think it kind of makes a little more sense to me to add it at the end. It's not going to change the answer, and it's correct if you put it in front. But so let's double check this. So this is 7 more than twice the difference of a number and 6. So twice the difference of a number and 6, that's the difference of a number and 6. Twice that, and we want 7 more than that. Okay, so that would be it. That's your answer right there. You could simplify this, but I'm happy to just kind of leave it there as it is. Okay, all right. How about all right, what does the rest say here? So consider the scenario in example 1. We have written an expression that will figure out how much money Mark has in his bank account after X weeks. Yeah, that's what we did there. If we wanted to know how much Mark has in his account after 13 weeks, all we have to do is take the X and put a 13 in there, right? So this idea, what I just talked about there, is called evaluating. So you get an expression, like a little formula basically, that's like, hey, if you ever want to know after a certain number of weeks how much money he has, you just plug in your number where the X is and it will tell you. Okay, so example 3 here is asking you, hey, evaluate the expression 15 plus 5x when X is 13. So this is basically saying, hey, if it's been 13 weeks, how much money would Mark have in his account? So where the X is, we're going to put a 13. So we say here in algebra that we are evaluating the expression when X equals 13. So what would this be? This would be 15 plus order of operations, right? Parentheses, exponents, multiplication. So there's multiplication here. 5 times 13 is 65. 15 plus 65 would be 80. So what this means is we say that the value of this expression after evaluating when X is 13 is 80, which means after 13 weeks, what? Mark would have $80 in his account. So this is kind of a useful tool to have. Okay, evaluate the expression x squared plus 4x plus 1 when x is 3. So what we're going to do here is we're going to take our expression, and wherever we see an x, we're going to put a 3 in. Okay? So wherever there's an x, we're going to put a 3 in. We would like to know what this number actually is, what we would get as a resulting number if we were to actually plug in a number 3 here. So, all right. What do we have here? We have 3 squared is 9. And then 4 times 3 is 12 plus 1. And then we're just going to add these all up. So 9 plus 12 plus 1 would be 22. So if you would like to know what this number actually is, when you put a 3 in where the x is, apparently it's 22. All right, let's look at example 5 here. Evaluate the expression absolute value of 1 minus 4x for x is equal to negative 2. So we're just going to do the same idea. So we're going to say, hey, this is equal to 1 minus 4, and then wherever we see the x, we're just going to throw in the number there, so negative 2. And now we're going to evaluate. So this should just be a number here when we're all done. So what is this? This is going to be 1. There's some multiplication going on here. So it's the absolute value of 1, and then if we have negative 4 times negative 2, that's positive 8. So plus 8. And then what is this? This is the absolute value of 1 plus 8 is 9, and the absolute value of 9 is 9. Okay? All right. How about example 6? Evaluate the expression 2x minus 3y when x is 5 and y is 6. So what we're going to do here is we're going to say, okay, cool. So this is 2x minus 3y, and then for the x, it's telling me it wants me to plug in 5 for the x, and it wants me to plug in 6 for the y. Okay? So 5 for the x, 6 for the y. So this is just really easy. 2 times 5 is 10. Minus 3 times 6 is 18. So this would be 10 minus 18 would be negative 8. Okay? And that is how you deal with expressions, and that is how you evaluate expressions.